So to help us understand the question, let us first draw a diagram. So I have a motorist, okay, and it's traveling. So I'm going to just represent the motorist like a particle. So it's traveling at 13 meter per second when it approaches a traffic light, okay, which turns red, and he is now about 25 meters away. So let me just put in the 25 meters away. So this is 25 meters away from the traffic light. So this is the traffic light, okay. His reaction time is 0.70 seconds. So what does it mean? It means at the point where he starts seeing, all right, he needs time to react. So to a point where at 0.70 seconds later, he's actually traveling with constant velocity. So let me just denote the acceleration. He's traveling with constant velocity, and the acceleration is equals to 0 meter per second squared. Okay, after which he starts braking. When he starts braking, it means at this point in time, he is still traveling at 13 meter per second, but he brakes. So he's going to brake. So he now has an acceleration of 4.5 meter per second squared, okay, but in the opposite direction to his velocity, so he's actually slowing down, okay. So how far from the stop line will he be? So we're going to assume that he's going to stop a distance of all right, a distance away from the stop line somewhere here, okay. So if we find that the net distance that he has traveled is actually greater than 25 meters, he's going to actually stop after the stop line. So if he if it travels actually less, so then the value, then he will actually stop at this point instead, and the total distance that he travels should be 25 meters. So to know how far he's going to stop, we need to know what is the total distance traveled. So in this case, we see there's actually two parts of a journey. The first part of the journey where he is traveling at constant velocity, and the second part of the journey where he's traveling at constant acceleration, okay. So before we solve anything and apply equations of motion, I'm going to first look at the distance that he traveled during the point where he's during his reaction time, okay. So that's the first part. So let me write that down. So distance traveled during reaction time, okay, and this part is actually constant velocity. There is no acceleration. So simply to find the distance traveled, we just take the speed times the time, and the speed itself, so it's just v times t, okay, or I'm just going to call it u times t, and it is 13 meter per second multiplied by the time taken, which is 0.70 meters, and that will give me 9.1 meters, okay. So you put this into a calculator, you get 9.1 meters. Then in the second part of the journey, this is actually where we are going to apply equations of motion. Now, when we apply equations of motion, most importantly, what we need to do is set up the system. Okay, to set up the system, it means we need to look at where are we going to take initial point where we start measuring, and then we are going to also look at therefore what is the sign convention. Okay, now if you look at the equations of motion, I'm going to write it down, and as a first time learning kinematics, it may be actually good habit to always keep writing down the equations of motion, and eventually for every single question, if you keep writing down your equations of motion, you start memorizing it, okay. So I'm going to write down v equals to u plus at, okay, s equals to ut plus half at squared, v squared equals to u squared plus 2as. Now, you do note that actually this equation of motion, it actually sets for you where your reference point of displacement should be. Let's look at this particular equation. Now, if I look at this particular equation and I substitute t equals to 0 here, what do you notice about the s? You realize it's going to give you s equals to 0. So inherently, if I'm going to apply equations of motion to this second part of the journey, I have to reset and set t equals to 0 here. And this is the point where my s is equals to 0 as well. The next thing I need to do is define my sign conventions, because these equations of motions are vectors equations. So in vectors, we need to be very, very clear what is the positive direction and what is the negative direction. So since the car is actually going to travel towards the right, I'm going to set rightwards as positive. Okay, so this is going to be my sign convention. All right, so I'm going to set rightwards as positive. This is another way which I'm going to present and tell people that I'm actually using rightwards as positive. I'm going to write down what we have. Now eventually it comes to a stop, so we need to know what is the information we have. We're at the final stop line. So at the final stop line, your v is going to be equals to 0. Initially, he's going to start off at 13 meters per second. And since it's towards the right, so it's actually positive. And then finally, he's going to come at 0 meter per second. Now, what do we need? Okay, we need to find what is the distance he has traveled during that time. So s is what is unknown. Now, you also notice something about these equations of motion. For these equations of motion, every one of them has a term of acceleration. So what's the acceleration at this point in time? So acceleration for this part of the motion, we see is actually 4.5 meter per second. But I'm going to put in my sign convention now. We note that since I've taken rightwards to be positive, my a is actually negative 4.5 meters per second. Now, these are all the information I have. I do not have what is the time it takes for me to slow down. So with these information, which equation do I use? Checking the three equations of motion, we see that the most suitable equation with one unknown without any time factor is my last equation here. So I'm going to use that equation. So I'm going to write using v squared equals to u squared plus 2as. Then what I will have is I will have 0 squared equals to u squared, which is 13 squared plus 2 times minus 4.5 times s. So substituting and then rearranging it, what I will have is I will have s to be 18.8 meters. So is this answering? Always double check. Have I fully answered the question? No. The question wants how far from the stop line will he stop. So the next thing we need to do is actually find out what is the total distance traveled. So the distance traveled, total distance traveled, is distance traveled in the first part of the journey, which is 9.1 meter, and this is for distance traveled in the second part of journey. So this is the distance traveled in second part of journey. Okay, and what I will have is 9.1 meter plus 18.8 meters, and that gives me 27.9 meters. This means actually from where to where he stops, he has traveled in all, right, 27.9 meters. So the distance, right, that he stops after the stop line is 27.9 meters minus 25 meters, and that gives me 2.9 meters. Okay, so he will stop beyond the stop line. All right, so that's the answer for the example.